Okay, so let's start off by writing our function rule. So we have order pairs. Actually, we're going to start by doing domain and range. Let's start with that. So your domain is your x value. So domain is x. So that would be these numbers here. Okay, those are my x values. Let's go ahead and list those numbers from smallest to largest. So of those 4 numbers that are underlined in red, what's the smallest number? -7. After -7, what's the next number?
3.
After 3?
4.
And after 4?
6.
Okay, now these brackets, we use these brackets. Just try your best to make them. They're just like a squiggle. The only way I think about it is it's a parentheses with a nose. We don't use parentheses because this is not interval notation. This is a discrete function, meaning that it's 4 points, not connected. And because it's discrete, the domain is just numbers. Okay? Now let's talk about our range. So for our range, these are our numbers. I'm going to underline those in blue. What's the smallest number I have underlined in blue? -6. After that, it's what? After -4. And after -3? 7. All right, who had that for their domain and range? Any questions about how we did that? So for homework 1, there's some questions where you have to tell me the domain and range. And if it's just numbers, you just tell me the numbers from smallest to largest. If there is a number that repeats, you don't have to write it twice though. Okay, this one is 1-to-1, nothing repeated. So your domain have 4 numbers and your range have 4 numbers. Okay, so now let's write our function rule. So when we write our function rule, we're looking at what is happening to the y value. So from x I went from 3 to -3. Then I went from 4 to -4. 6 to -6. -7 to +7. So what am I multiplying my x value by to get the y value? What number am I multiplying it by? Don't be shy. You probably right. What number is it? -1. So my function rule is simply y equals -1x. So the y value is equal to -1 times x. That's your function rule. All right, let's look at number 2. So we have our domain. So again, these are my numbers in my domain. So we have, what's the smallest x value that I have underlined in red? -1, good. And after -1?
0.
After 0?
2.
After 2? 4, good job. And now we're gonna write our range. So these are my range. What's the smallest y value? -3. And after -3?
0.
After 0?
6.
After 6? 12. So it's kind of hard to tell with this first point because that could be anything. We can multiply 0 by any number to still get 0. So we really can't tell the function rule from the first point. But if we look at our second, third, and fourth, so 4 times what number is 12?
3.
So, and let's make sure it's always 3. So 4 times 3 is 12. That's right. Is 2 times 3 6?
Yes.
Okay. Is -1 times 3 -3?
Yes.
So my function rule would just be 3x. Y equals 3x. All right. Take out your reveal book and go to page, I think it's page 16. and reveal. So we'll do the rest of those questions tomorrow. Okay, so in this table, the x coordinate when y is 0, all right, so that would be this right here. So what is the x value when y is 0? What is x? 8. So the x coordinate when y is 0 is 8. Therefore, the x-intercept is 8. In the table, what is the y value when x is 0? 15. So that first number at the top, that's my y-intercept. So that would be 15. The y-intercept is 15. So in this table, what is the meaning of the x-intercept? So in this table, x measures what? What does x measure? Time in what unit? Seconds. So in this meaning, in this, the context of this question, the x-intercept is the time in seconds. And you always want to specify the unit, because we can measure time many, many ways. We could do seconds, minutes, hours, days, years, months. So you want to make sure we're being clear on what that unit is for time. So time in seconds after the rocket is launched that it returns to ground. Because on this point, x is 8, y is 0. So in other words, it takes 8 seconds after he drops the rocket. It's going to take 8 seconds for it to hit the ground. That's what that is. That's the meaning of the x-intercept. The y-intercept is the, what is y, what does that say? At the top of your chart, what is y? Height in what unit? Feet. So it would, the y-intercept is the height in feet. So that's how high he was, Ricardo was, when he dropped the rocket. So when he let it go, he was 15 feet high, and it took 8 seconds for it to hit the ground. All right, so that's the meaning of that. Any questions about that example? All right, so that's the end of our x and y intercept. So now we're going to talk about symmetry, and we're only going to talk about 2 types of symmetry. We're not doing even and odd, and that's why I took that out of homework 2. So there's 2 different types of symmetry: line symmetry and point symmetry. So we're going to talk about them both. Line symmetry, if a graph has line symmetry, that just means that it can be reflected across a vertical line. Okay? That's what that means. If you need to borrow a highlighter, I have highlighters on my desk. I just like to highlight, but that's just me. Okay? Line symmetry means that if you draw a vertical line, it's going to divide it in half. And one thing I want you to write in your notes is that all parabolas have line symmetry. So all parabolas have line symmetry. So if it's y equals x squared, it's going to have line symmetry. Now where that line is, that's going to change. The line won't always be in the same place, but for every single parabola, there is a place where you can draw a vertical line and have perfect symmetry. So it says that the line dividing the graph into 2 matching halves is called the line of symmetry. Each point on one side is reflected in the line to a point that is equal distance, and that word just means it's the same distance, That just means it's the same difference, same distance. Do a little annotating here. That's what that means. From the line to the opposite half. So for this example here, in your book, notice how you have this red line. See that red line? That's your line of symmetry. Okay? So this is your line of symmetry. This is the line that divides the parabola into two equal halves. So this side of your parabola, this side is exactly the same as this side. They're two equal halves. Any questions about that? Pretty simple, self-explanatory. All right, let's go to the next one. Let's talk about the other type of symmetry. Now, this one is a little harder to visualize, and this is point symmetry. For point symmetry, that means that in order to get your symmetry, you actually have to rotate it 180 degrees. All right, so you kind of have to visualize this graph being turned 180 degrees. 180 degrees, if I rotate it, that's just half a circle. Half a circle. So if I go half a circle, if I rotate it 180 degrees, it's going to be exactly the same. The point about which the graph is rotated is called the point of symmetry. Now in this graph, the point of symmetry is this red dot. And what is that point called? What is the ordered pair for that point? The origin is 0, 0. So this graph has a point of symmetry at 0, 0. So if you could take this and rotate it 180 degrees, it's going to be an exact match to where it started. Okay? So now let's look at a couple of examples. Not doing that. Go to page 17 and let's look at identifying the symmetry. So point symmetry, 180 degrees rotation about any point on the graph is going to be the original graph. So identify. So this first one has point symmetry. So this first one has point symmetry. And because this is a line, I think the easiest way to find that point would be to use your y-intercept. So if it's linear, we're going to use our y-intercept as our point of symmetry. So where is the y-intercept for this graph? For example, A. Where is that point at? The y-intercept would be right here. And how would you write that as an ordered pair? Would it be 1, 0 or 0, 1? 0, 1. Good job. This is a parabola. And what did I say about parabolas? All parabolas have what kind of symmetry? Line symmetry. So this graph has line symmetry. And where can I draw the line? To divide it, it says it's at x equals -2. So I'm going to draw a dashed line. Go ahead and draw a dashed line or a solid line. It doesn't really matter. This is where I can draw that line. And when I draw that line, it's dividing my parabola into two symmetrical pieces. This is what that would look like. So the orange piece is exactly the same as the green piece. If I draw my line right here, if I move that any other place, it's not going to be symmetrical. Okay? So x equals -2 would be my line of symmetry. Any questions? All right, almost done, guys. Go ahead and look at C and D. Now, this has no symmetry. So not all graphs have symmetry. It is possible to have no symmetry. So in other words, there isn't a place that I can draw a line. So if I draw a line right here, okay, this side doesn't look the same as the left. And there isn't any place that I can draw a line and get symmetry. If I move it over, it still doesn't match. If I try to rotate it 180 degrees, it's just going to be upside down. But that doesn't look the way it would originally. So this graph does not have any symmetry. So there is no symmetry. This last one has point symmetry. Where do you think that point is? Because they didn't tell us. Sienna? 0, -2. Good job. Right here. Okay. That is my point of symmetry. If you were to take this and rotate it 180 degrees, it would look the same. Okay. So the point of symmetry, this graph has point symmetry, and it's 180 degrees about the point, and the point is 0, -2. That is where we could rotate it, and it's going to match the original graph. Any questions about today's lesson? Okay. So like I said, I did make some revisions to homework 2. I did update Canvas. So this is your new homework 2. So homework 2, I shortened it. Okay. For 31 through 33, I only want you to tell me X and Y intercepts.